In pavement structures, flexible base and subgrade layers play an important role in supporting the surface layer and providing a working platform during construction. The compressive strength of those materials is one of the critical properties required in TxDOT's standard specifications to make sure the materials provide the required support. To measure the compressive strength, test specimens are compacted with an impact hammer in the laboratory, based on TxDOT test procedures TEX 113E for base and TEX 114E for subgrade soil. However, the precision of compressive strength results by impact hammer compaction remains a concern that can result in conflicting test results regarding whether a material meets specification requirements. These conflicting test results generally require referee testing, which may cause project delays and increase the cost of procuring suitable materials. In TxDOT Research Project 0-6883, the research team analyzed whether the use of the Superpave gyratory compactor, or SGC, to compact test specimens would improve the precision of compressive strength results for base and soil materials. Researchers found that SGC compaction enables more uniform compaction of specimens and reduced variability of strength test results as compared to the impact hammer. This video presents step-by-step instruction for compacting base material with the Superpave gyratory compactor for compressive strength tests. For compacting base material with the SGC, 6 individual samples should be prepared using the maximum dry density and optimum moisture content predetermined by test method TEX 113E. For each sample, the mass of air-dried material and weight of water should be recalculated based on the SGC mold size, normally 150 millimeters in diameter and 200 millimeters in height. After allowing the samples to stand for 18 to 24 hours, divide the material passing and retained on the 7/8" sieve into 4 equal portions and put them into separate bowls. Next, construct the layers in the SGC mold. This step is similar to test method TEX 113E section 6.16. However, for SGC compaction, the sample in the mold should be constructed in 4 layers, but compacted in 1 lift. First, put a non-porous paper disc in the bottom of the mold and place some of the material passing the 7/8" sieve to cover the bottom of the mold with approximately 1/4 inches of material and level with a spatula. Hand place all of the aggregate particles retained on the 7/8" sieve contained in 1 bowl. Next, pour the remaining portion of material passing the 7/8" sieve into the mold and level the surface with a spatula. Now, the first layer is completed. Repeat the steps for constructing the first layer for each of the 3 remaining layers without performing any compaction. When the loose material extends above the SGC mold, carefully press the material into the mold by hand or a slide hammer. The surface of the last layer should be flat and free from large aggregate. After constructing the layers in the SGC mold, place a non-porous paper disc on the surface of the sample and load the mold into the compactor. Now the specimen is ready to compact with the SGC. The compaction procedure is in accordance with test method TEX 241-F, sections 8.1.5 through 8.1.10. The compaction should be height controlled. Use gyratory compaction parameters of 600 kilopascals of pressure, 1.16 degree gyration angle, 30 gyrations per minute, 200 millimeter specified height, and up to 999 gyrations. If the specimen fails to reach the specified height after applying the maximum number of gyrations, set higher compaction pressure in increments of 100 kilopascals and compact the sample. After the compaction is complete, extrude the specimen from the mold and record the specimen weight. Immediately after recording the weight, enclose the specimen in a triaxial cell with porous stones and paper discs on top and bottom. Allow the specimen to set for 24 hours at room temperature, and then perform the compressive strength test in accordance with test method TEX 117E Part 2. This video demonstrates how to use Superpave compaction for flexible base to reduce variability of compressive strength test results. The research was performed under TxDOT Research Project 0-6883.